Now we will read about units of Kc. Kc has no unit when the number of moles of reactants and products are equal. For example, when H2 react with I2, it forms 2HI. Here 1 plus 1, 2 moles of reactants are present. Here 2 moles of products are present in this balanced chemical equation. So first of all, we will write Kc, equilibrium constant expression, which is the ratio of the product or the concentration of product to the product of concentration of reactants. Here H2 and I2 are reactants, so we will write H2 and I2 as denominator and Hi are products, so we will write Hi as nominator. Now we will determine the unit of Kc by writing the unit of concentration. Unit of concentration is mole per decimeter cube, as these concentrations are expressed in mole per decimeter cube, so we will write here mole per decimeter cube. Here coefficient 2 is present, so we will write 2 as exponent at the top of Hi. So we will write mole per decimeter cube whole square divided by, here concentration unit of H2 is mole per decimeter cube, so we will write mole per decimeter cube. Similarly, we will write concentration unit of I2, which is mole per decimeter cube, again because powers of H2 and I2 are 1 and 1 here. So here 2 moles mole per decimeter cube with the power of 2 cancels the mole per decimeter cube of reactants here. So here Kc has no unit because number of moles of reactants are equal to the number of moles of products. Similarly, Kc has unit when number of moles of products are greater than the number of moles of reactant. Here number of moles of products always greater or less than the number of mole of reactants, then Kc has unit. Here for example, in this case we will study that if number of moles of products are greater than the number of moles of reactant, then Kc has unit. For example, N2O4, it gives us 2NO2. Here we will write Kc, equilibrium constant expression, which is product of the concentration of product to the product of the concentration of reactant. So we will write NO2 raised to the power 2. Here 2 coefficients is present, so we will write 2 in the form of powers divided by N2O4. Here 1 coefficient is present in this balanced chemical equation, so we will write 1 time N2O4. Now we will write the unit of concentration, which is mole per decimeter cube raised to power of 2 to the mole per decimeter cube power of 1. Here we can write this mole per decimeter cube whole square as mole per decimeter cube into mole per decimeter cube divided by mole per decimeter cube. Here this mole per decimeter cube cancel mole per decimeter cube one, which is here 1 mole per decimeter cube left, so we will write mole per decimeter cube, which is the unit of Kc here. Here unit of Kc will become mole per decimeter cube. Here Kc has unit because here number of moles of products are greater than the number of moles of reactants. Here 2 moles of products are present, here 1 mole of products, number of moles of reactants are present, so 2 is greater than 1. So here as products are greater than the number of moles of reactants, so that's why Kc has unit mole per decimeter cube. Similarly, Kc also has unit when the number of moles of products are less than the number of moles of reactants. For example, when N2 react with H2, it form NH3. So here we will balance this chemical equation by writing 2 here. Here hydrogen will become 6, so we will write 3 here to balance this chemical equation. Now we will write Kc equilibrium constant expression, which is the ratio of the product of concentration of product to the product of concentration of reactants. So here we will write products as nominator and reactants as denominator, raised to the powers, which are coefficients here. Here 2 coefficient is used in case of NH3 in front of NH3, so we will write 2 here. Here 3 coefficient is present, so we will write 3 here. Here 1 coefficient is present, so we will write N2 one time. Here by writing the unit of concentration, which is mole per decimeter cube, mole per decimeter cube whole square divided by mole per decimeter cube into mole per decimeter cube the power 3. Here to solve this expression we will write mole per decimeter cube the power 2 divided by mole per decimeter cube. Here we will write this mole per decimeter cube whole cube in this way, mole per decimeter cube square into mole per decimeter cube. So here this mole per decimeter cube whole square cancel the mole per decimeter cube whole square. Here the unit which is left over here, mole 1 over mole per decimeter cube whole square. So here this case he also has unit 1 over mole per decimeter cube whole square, or we will write also in this way, mole per decimeter cube whole square per mole square, such as in this way, decimeter cube whole square. Here it is present in inverse, so when we write this as this mole per decimeter cube whole square in the nominator, in the form of nominator, so we will write decimeter cube whole square per mole square. So Kc has unit in this case. Here the number of moles of products are less than the number of moles of reactants. Here 2 moles of products are present. Here 3 plus 1 4 number of moles of reactants are present. So Kc has unit when the number of moles of products are less than the number of moles of reactants.